divide A, 31.95 divided by 4.5, B, 782 divided by 0.34, and C, 0.17 divided by 0.008. Let's do a few long division problems involving decimals. I'm going to begin with A here. Let's set this one up. 31.95. 31.95 goes inside the long division box, divided by, in front goes 4.5. Before we get started with the long division process here, we have to talk about the placement of the decimal points. Turns out that the long division process cannot be applied if we have a decimal number in front of the long division box. However, that doesn't mean that there's no way to solve this problem. There is a way for us to get the answer here. What we can do is take this decimal point in the 4.5 and we're going to move it one place over to the right. So that 4.5 becomes 45 point. 45 point is just the whole number 45. Now whenever you move a decimal point out in front of the long division box, you also have to move the decimal point inside in exactly the same way. So we need to move the decimal point inside one place to the right. It ends up between the 9-digit and the 5-digit. The decimal point in our answer will lie right above this new position of the decimal point. So let's go ahead and get that decimal point placed in our answer before we begin the process. Now, why can you do something like this? What's going on? We'll talk about that after we do a few of these problems. Let's get the hang of this process, and then we'll talk about why we can make this movement, why we can make this change in the decimal points. Now let's go ahead and start our long division process here. We now have a 45 out in front. Does 45 go into 3? No. So I look at 31. Does 45 go into 31? Not even one time. So I look at 319. I have 319 in front. 45, how many times does that go into 319? Well, 319 is pretty large. I'm just going to make a guess here and try 45 times 8. 45 times 8. 8 times 5 is 40. Write the 0, carry the 4. 8 times 4 is 32, plus 4 is 36. I get 360. Well, that's too big. That's bigger than 319. So let me try 45 times 7. Maybe that will work. 7 times 5 is 35. Write the 5, carry the 3. 7 times 4 is 28. Plus 3 is 31. I get 315. 315 is smaller than 319. So 45 will go into 319 7 times. Now that 7, I got to write directly above the 9 here. 7 times 45 is 315. We just figured that out. And now I can subtract. 319 minus 315, 9 minus 5 is 4. 1 minus 1 is 0. 3 minus 3 is 0. So we just get 4 after we subtract. After we subtract, we get to the bring down step. So bring down the next digit, that's a 5. How many times does 45 go into 45? Well, that's going to be 1 time exactly. Now notice the 5 was just to the right of the new position of the decimal point. So the 1 that I write up above will go just to the right of the new position of the decimal point. 1 times 45 is 45. 45 minus 45 is 0. I got 0 remainder here, so we're done with the long division process. Our answer is 7.1. I've written our answer for A here, 7.1. Let's move on to the second problem, B, 782 divided by 0.34. Let's go ahead and set up the long division box. 782 goes on the inside of the long division box. Out in front goes the 0.34. 0.34. So before we begin the division process here, we have to think about the decimal point placement. I have a decimal in front of the long division box. Whenever I have a decimal in front, I have to move that decimal point over in order for the long division process to work. Here, I need to move my decimal point 2 places to the right in order to move it all the way to the right of that number in front. 0.34 then becomes 34. 0.34 is the same as the whole number 34 now. I also need to move my decimal point inside the same number of places. Now 782 is a whole number. Where does the decimal point start out in this whole number? Well, the decimal point in a whole number starts out just to the right of the ones place. 782 is 782 point. The decimal point does not start out anywhere near the 7. That's in the hundreds place, then the tens, then the ones place here. The decimal point starts out just to the right of the ones place. Now I still need to move it over 2 places to the right. In order to do that, I can extend my long division box and write 2 zeros on the end. Then I have 2 places to move past so that I can place the decimal point in its new position. I move the decimal point 2 places to the right in front, and I also move the decimal point 2 places to the right inside. I have to move the decimal point the same number of places in both positions. The decimal point in my answer will be right above the new position of the decimal point inside the long division box. Now let's go ahead and start the long division process. I just have 34 in front now. Does 34 go into 7? No. Does 34 go into 78? Yes, let's try 2 times. What's 34 times 2? 2 times 4 is 8. 2 times 3 is 6. I get 68. That's going to be the best I can do. So I write the 2 directly above the 8 because I'm just using the 78 now. 2 times 34 is 68. After I multiply, I subtract. 78 minus 68, 8 minus 8 is 0. 7 minus 6 is 1. I get 10 after I subtract here. After I subtract comes the bring down step. I bring down the next place, which is a 2. I am now thinking about how many times 34 goes into 102. Well, we know 2 times is smaller than 102. What about 34 times 3 times? 3 times 4 is 12. Write the 2, carry the 1. 3 times 3 is 9, plus 1 is 10. I get 102. 34 times 3 is 102 exactly. So I know I can write a 3 up above the 2 I just brought down. 3 times 34 is 102. And now I subtract. 102 minus 102 is going to be 0. Now I got 0 subtracting, but I'm not done with the long division process yet. You can never stop the long division process until you get all the way to the new position of the decimal point. Notice that I have 2 more places here to the right of the 3. There's a place above each one of these zeros I added on before I get to the decimal point. So I have to continue the process. I bring down the next 0, and I ask myself, how many times does 34 go into 0? 34 goes into 0 0 times. Write a 0 up above. 0 times 34 when I multiply is 0. Subtract 0 minus 0 is 0. And I bring down the next 0. I continue the process. How many times does 34 go into 0? I still have 0. 0 times. Write another 0 up above the 0 I just brought down. This 0 times 34 is 0 again. 0 minus 0 is 0 again. And finally, I'm done with the process because I've gotten all the way over to the decimal point. That's when I can stop. My answer here is 2,300 point. That's the same as the whole number 2,300. Just next to this here, I'm going to write 2,300 without the decimal point. Because we got a whole number answer, we don't need to write the decimal point in our answer. And also one last comment here. If you knew that you had to fill in these places above these 2 zeros with zeros, you don't need to write down all the 0 subtraction steps. But it's okay to go through them also. Each time you bring down a digit, you need to write a number up above. So there we have it. Our answer is 2,300. So our answer in B is 2,300. We got a whole number answer for that division problem. Let's move on to C, 0.17 divided by 0.008. Let's set up our long division box once again here. Inside the long division box goes 0.17. Out front goes 0.008. Remember, when I write division this way, the first number always goes inside the long division box. The second number goes out front. Before we begin the process here, we got to think about the placement of the decimal points. We have a decimal number out in front of long division. When you have a decimal number out front, you need to move the decimal point all the way over to the right. So I need to move this decimal point 1, 2, 3 places to the right so that it's just to the right of the 8. That turns this number in front into a whole number. It becomes an 8. I also need to move my decimal point inside the same number of places. So I need to move it 1, 2, 3 places. In order to have a third place, I write a 0 on the end. So I can move this 1, 2, 3 places to the right. The new position of the decimal point is just to the right of my new 0. In my answer, the decimal point will be right above that new position. This problem has become just the whole number 8 into 0.170. That's the same as 170. Zeros in front of a whole number don't add to the value of the whole number. So 0.008 is just 8 into 0.170 point is just 170. Now let's go ahead and start the long division process here. how many times does 8 go into 0? Well, it doesn't go in. To 1, well, it doesn't go in. To 17. By the way, I haven't had to write zeros up on top yet because I'm still to the left of the decimal point. I don't need to write those zeros yet. Does 8 go into 17? Yes, 8 will go into 17 2 times. I write the 2 above the 17. 2 times 8 is 16, and I subtract. 7 minus 6 is 1. 1 minus 1 is 0. I get just 1 after I subtract. Now I bring down the next digit, bring down the 0, and I ask myself, how many times does 8 go into 10? 8 goes into 10 just 1 time. Now this 0 was just to the left of the new position of the decimal point. So my 1 goes right above that 0. It's also to the left of the decimal point. 1 times 8 is 8. I multiply. Then I subtract. 10 minus 8. 10 minus 8 is 2. And now I've gotten to my decimal point, but I still have a remainder here. Because I'm at the decimal point, I can extend my long division box and write an extra 0 on the end. That will not change the value of the new number, the 170 point, that I have inside the long division box. I can add a 0, bring it down, the 2 becomes 20, and now I continue the process. How many times does 8 go into 20? That's 2 times. 2 times 8 is 16. I subtract. 20 minus 16 is 4. I can add another 0 on. I continue the process, bring down this 0. The 4 becomes 40. I ask myself, how many times does 8 go into 40? 8 goes in 5 times exactly. 5 times 8 is 40. And when I subtract, I get 0. I have no more numbers to bring down. I'm to the right of the decimal point. I have a 0 from subtraction, so I'm done with the long division. Our answer here is 21.25. I've added the answer to C to our list, 21.25. Now we're not going to do any more long division problems, but if you're wondering why we can move the decimal points in the way we have in these long division problems, I'd like to give you an explanation of that. Now this explanation isn't easy and it is rather abstract, but let's take a shot at it. Now we're going to get started by just thinking about an easy division problem, a very easy division problem, sort of like 6 into 24. How many times does 6 go into 24? Well, 6 goes into 24 4 times, because 4 times 6 is 24, and it comes out very nice, of course. Now let's look at another long division problem. I'm going to write 60 into 240. It's similar to the one we just looked at, but instead of 6 in front, I wrote 60. Instead of 24 inside, I wrote 240. 60 is a lot bigger than 6. 240 is a lot bigger than 24. But how many times does 60 go into 240? Well, 60 times 4 is 240. It just goes 4 times. The answer to this problem is the same as the answer to this problem. 4 times 60 is 240. Subtract, we get 0. Let's look at just one more. What if I took 600 into 2,400? 600 into 2,400. Well, again, 600 is way bigger than 6. 2,400 is way bigger than 24. But can you see 600 is just going to go in 4 times, because 600 times 4 is 2,400. The answer to this division problem is just 4. Each one of these 3 problems has the same answer, even though larger and larger numbers are involved. Now here's the abstract idea. If you take a division problem, and if you multiply both in front by 10 and inside by 10, 60 is 6 times 10, 240 is 24 times 10, you get a new division problem with the same answer. If you multiply in front by 100, 600 is 6 times 100, and inside by 100, the same number, 24 times 100 is 2400, you get a new division problem with the same answer. If you take any division problem and multiply both in front and inside by the same number, you'll get a new division problem with the same answer. So what happens when we're moving decimal points? If you move a decimal point one place, that's a shorthand way of multiplying by 10. Multiplying by 10 in front and inside gives you a new division problem with the same answer as the original. When you move a decimal point 2 places, both in front and inside, that's a shorthand way of multiplying both numbers by 100. If you multiply both numbers by 100, you get a new division problem with the same answer as the original. So as long as you move the decimal point the same number of places, both inside and in front, you're changing the problem in a way that gives you a new problem that has the same answer as the original, just like all these problems have the same answer. Now, that's kind of deep. If you don't get it all, that's just fine. Go back, work some problems, learn the technique, and then maybe think about this ending again.